Hello students, this is the Unit 4 Lesson 4 video on rotations. We're going to be talking about this type of transformation in which you take a shape, a pre-image, and you rotate it around a center of rotation. There are a number of different ways that you can do a rotation, including different directions to rotate and different amounts to rotate, whether you rotate it 180 degrees or only 90 degrees or 270 degrees, and we could also change the direction in which we rotate. So there's a lot of different things that you have to learn about rotations, but first let's take a look at the learning target. The target is that we're going to be identifying centers of rotation and also degrees of rotation. Those are the two main pieces of information that we can identify for a rotation: where it's centered and how much it's spun around. And we're also going to be developing definitions for rotations using transformation notation. So those definitions are going to be kind of like the other notations that we've used. Remember that for translations, we use the big capital T, and with reflections, we used a lowercase r. For rotations, we're going to be using an uppercase R. For the do now, it says, how far around did each shape spin? We're going to identify the degree measurement of each rotation around the origin below. When the problem says about the origin, that's a geometry way of saying around the origin. All right, pause the video, try this one out, and then come back to see if you get it right. All right, as you probably have guessed, these are all rotations. We call this a rotation of 180, this is a rotation of 270, and this is a rotation of 90. In order to get those individual measurements, here's what we do. My trick is I'll pick two corresponding points. And remember, corresponding points are points that are in the same place, but different shapes. So for example, this is point J, that corresponds to point J prime, which is here. This is point U, that corresponds to U prime in this shape. And this is point X, which corresponds to point X prime. In order to figure out the number of degrees we rotate, we just draw a line from each of those corresponding points back to the center of rotation. Kind of like you can think of it as maybe you're standing here in the middle and you're holding a dog on a leash and that dog is like running around you. That dog in this case, in this extended metaphor, is these corresponding points. And we just figure out how much it spun around you. In this case, we're going from J to J prime. And remember, we're spinning around counterclockwise. I said in one of the previous videos that counterclockwise is the default direction. Anyway, that direction brings us around an entire straight line, which means I've gone around 180 degrees. Looking at this problem, I've gone from U around to U prime. Looks like I've spun 1, 2, 3 quadrants around. In other words, I've spun around 270 degrees. I'm not taking this part of the angle because I'm figuring out how much we've gone around counterclockwise around that center of rotation, which is the origin. Same thing here, I'm starting at point X and I'm swinging around to point X prime. That swing, that counterclockwise direction, is only by 90 degrees. That's why I'm saying that this is a 90-degree rotation around the origin. So notice in all of these cases, I've identified two different things. It's important for you to identify two different things about the transformation. First, we're going to identify the measurement of degrees, and then we also have to say that it is a rotation, right? You need those two different things. I'm going to show you now how to write these in so-called transformation notation. And that transformation notation is here. Big R, capital R for rotation of 180 degrees. Big R, which stands for rotation of 270, and big R of 90. Now, how do I differentiate this from reflections? Well, if you remember from the reflections lesson, we used a lowercase r for reflections. So uppercase R for rotations, lowercase r for reflections. Let's talk about direction of rotation for a moment. We know that any rotation that we talk about, for a default, the default direction is going to be counterclockwise. So if it doesn't say which way to spin it around, your default is going to be counterclockwise. Some rare problems do ask you to spin counterclockwise, but don't worry, it'll actually say specifically you must rotate clockwise in that particular case. In addition, the default center of rotation is the origin, which is 0, 0. So most of the time it'll say rotate this shape 90 degrees. You don't have to worry about where the center is. The center is going to be the origin and the direction is going to be counterclockwise. You'll only change these unless it specifically states, you'll only change these if it specifically states to change the center and the direction. Let's take a look at some examples. In this first example, it's a rotation of 90 degrees. The rule is xy becomes negative yx. In other words, we switch the order of the two numbers and we change the sign of y. So whatever this y value is, it changes to its negative or its opposite. In this example, negative 3, 1 becomes negative 1, negative 3. what we've done is we've switched the order, so the 3 goes in the back and the 1 goes in the front, and we've changed the y value. You can see that this y value is positive 1. It changes to, you guessed it, negative 1. Same thing here, negative 1 comma 2, we're switching the order, so it becomes 2 in the front and 1 in the back. And then this y value starts off at positive 2, it becomes negative 2. The twist comes in with negative 1 comma negative 3. Remember, we're switching the order, so this negative 1 goes to the back and the negative 3 comes to the front. But notice, we're starting off with a y value and we change that y value to its opposite sign. So we're starting off with this y value, which is negative. We change y to its opposite sign, which is positive. Now with 180-degree rotation, it's a little bit different. We're going to change the value of x and change the value, or I should say, change the sign of x and change the sign of y, but I'm keeping it in the same order. So 5, negative 1 becomes negative 5, 1, right? All we've done is change the sign of both of these. 3, negative 3 becomes negative 3, comma 3. 4, negative 5 becomes negative 4, 5. Change the signs, but leave the order the same. And then for a rotation of 270 degrees, x comma y becomes y negative x, which is very similar to a rotation of 90 degrees. Remember, we switched the order, change y. In this case, we switched the order and changed the x. Listen, these are rules that you have to memorize. So you have a couple of different good options. One good option is to write them down on index cards and try to use them as flashcards to memorize, just like you would do in a science class or in a history class, or maybe like a language other than English. It's just stuff that you have to memorize. Another option that you have is just doing a lot of practice problems until it makes sense to you. A third option would be to always draw down on a graph paper and then say, well, I know how to rotate it by 270, that's spinning it around 3 times, and then figure it out like that. That's probably the most tedious and time-consuming option. I'd prefer that you not do that. All right, I'm going to move on to the model problem. It says state the coordinates of triangle ABC for a 90-degree rotation counterclockwise. Keep in mind, they didn't have to say counterclockwise, because if they don't say it, the default is counterclockwise, but it's nice enough that they said that. Also, it doesn't say where we're rotating it around, the center of rotation. So remember, if it doesn't say where we're rotating it around, the default is the origin. So we're going to be rotating it around this origin. How much? 90 degrees. So what you can do is look back at the previous problem, or in your case, rewind the video a bit and look for that rule. I'll pause the video for a moment so that you can try this out and then come back to see if you got it right. All right, first and foremost, let's remember that rule. X comma y becomes negative y comma x, which means we're going to be able to change all of the points into a negative y comma x. In other words, we're going to change the y sign and switch the order of the two numbers, which means we're going to need some ordered pairs for a, b, and c. So the first step is to identify the ordered pairs for a, b, and c. That's coming up right now. So now we have all of these points, a, which is negative 3 comma 2, b, which is negative 1 comma 2, and c, which is negative 1 comma 5. Now what we're going to do is apply this rule. We're going to say the rotation of 90 degrees of x comma y is leading to negative y comma x. So let's set it up for point A first. All right, here's the notation. We're saying a rotation of 90 degrees of the point A, negative 3 comma 2, gives us a prime, which is negative 2 comma negative 3. You can see that from the original point, we've switched the order from 3, 2 to 2, 3, and we've changed the sign of y. The y value sign, the 2, changes to its opposite, which in this case is negative 2. Now let's take a look at what it looks like on the graph. So from A, the original, the pre-image, we're turning it into A prime, the image. Remember the trick that I taught you at the beginning of the video. I'm trying to figure out whether it's a 90-degree rotation counterclockwise, and I've done the math. In order to make sure that I did it right, I'm going to tie both A and A prime back to the center of rotation and just make sure that that makes a right angle, or a 90-degree angle. And here you can see I connected A back to the center of rotation and A prime back to the center of rotation. I know that I'm spinning it around in a counterclockwise direction, so if I spin it from A to A prime, it sure looks like a right angle to me. Right? That is only 90 degrees. So I've proved that I've done it correctly for the first one. Let's take a look at the last two, which is points B and C. All right, and you can see in this case what we've done, we've spun the entire triangle around 90 degrees counterclockwise. And we're able to prove it in two ways, by looking at the graph and also by using that rule. The rule is by far the easiest way to do this, so your procedure should be write out the points that they're talking about, use the rule that you memorize or you have it on your flashcards, and then apply the rule every single time. One major question that sometimes students ask is, are we ever going to use different rules on the same shape? Like, am I going to transform one of the points by rotating it by 90 and one of the points by rotating it by 180? The answer is no. Whenever we're applying a transformation to a shape, we're going to apply the same exact transformation to all of the points of that shape. The check for understanding you are going to do in class. Keep in mind that this check for understanding is using a rotation of 90 degrees as well. It doesn't say where the center of rotation is, but you know by now that that center of rotation should be the origin. Fantastic. All right, this was the video on rotations. We talked about taking a shape and rotating it around the center of rotation and by analyzing how far around it spun. All right, folks, good luck studying.